Hello everyone. In this video, we are going to discuss a problem in which we are going to do synthesis by path generation of a four-link mechanism. So the question goes like this. We have to design a four-link mechanism in which we have an input link, a coupler link, an output link, and a fixed link. The position of these couplers are given by R1, R2 and R3, where R1 is equal to 55 millimeters, R2 is equal to 70 millimeters, and R3 is equal to 75 millimeters. All these positions are given with respect to the coordinate axis. We are also given with alpha 1, alpha 2, alpha 3, which are the angles made by the coupler links with respect to the fixed links, where alpha 1 is equal to 75 degrees, alpha 2 is equal to 50 degrees, and alpha 3 is equal to 40 degrees. Also, the angular displacement of the input links are given, that is theta 1 2 is equal to 30 degrees and theta 1 3 is equal to 70 degrees. The first step in solving the problem is to locate the three coupler points. We have been given the data about their lengths and the angles made by them with respect to the fixed coupler. So, we need to select a suitable location for the pivot A, which lies on the fixed link. In the question, they have mentioned the lengths as R1, R2 and R3. R1, R2, R3 are nothing but the lengths of A1E1, A1E2 and A1E3 respectively. In the diagram, we can see that we have plotted the points E1, E2 and E3 according to the data given in the question. Now that we have found the coupler points, we have to rotate the input links through their angular displacements given in the question, which is the angular displacement of A1, E2 is given by theta 1, 2, which is equal to 30 degrees. So we have to rotate A1, E2 in the counterclockwise direction by an angle of 30 degrees. During synthesis of such mechanisms, whenever we encounter rotations, we always do it in the anti-clockwise sense. Similarly, for the point E3, we have to rotate A1 E3 through an angle of theta 13, which is given as 70 degrees to obtain the point E3. The next step is to find the mid-normals for the points E1 E2' and E1 E3'. A mid-normal is a perpendicular bisector of the line joining the 2 points. Upon extending the perpendicular bisectors, we find that they intersect at a point. Now we have to name this point as B1. Now we have to draw the input link in three different positions, that is AB1, AB2 and AB3. The positions of B2 and B3 can be found by the rotation, and the angle of rotation is the same as the angular rotation for the input links which we have done previously, but this time in the clockwise sense. After drawing the three input link positions, we take a suitable point D1 on the fixed link. Now we join the point D1 to E2 and B2, thus forming the triangle E2, D1, B2. Now we are required to select another point D2 such that triangle E2, B2, D1 is equal to triangle E1, B1, D2. As you can see in the figure, we have the lengths of E2 and E2D1 and B2D1. With this, you can form arcs and easily find the point D2 and join the points D2 to E1 and B1. With this, you can get the triangle E1, B1, D2. Similarly, we have to join the point D1 to E3 and B3, forming the triangle E3, B3, D1. Now, we have to select another point D3 such that the triangle E3, B3, D1 is equal to triangle E1, B1, D3 in the similar fashion as the above. In the following figures, you can see that we have constructed two sets of triangles that are congruent. Now that we have found the points D1, D2 and D3, we are required to draw the mid-normals of D1, D2 and D2, D3. As I have mentioned earlier, mid-normal is nothing but the perpendicular bisector of the line joining the 2 points. Upon drawing the mid-normals of D1, D2 and D2, D3, we find that they intersect at a point. We name this point as C1. Now we join the point C1 to B1 and D1. In the figure, we have highlighted the part A1, B1, C1, D1, which is the required mechanism for us.